Next little bitty part is sketching binomial distributions. Hi and welcome back, and here we are talking about sketching binomial distributions. So in this video we're going to talk about how we can do these sketches, and there's a little bit of a tip over here of something you can do in your calculator to help you sketch these, and that's in a table function. So I'll show you that in a second. But if we want to determine the sketch of the following binomial distributions, we can do that by building our table and then sketching them. So to be honest, I probably won't go through this in too much detail, but I might actually build these on the calculator. So you'll see here I've said set binomial PD x5 0.1 and then set 0.51, and I'll show you that now. So if I go to my menu and go to the table function, now I'm going to delete these from previous work. And it's always a good idea to keep things clean, but you can always deselect them as well, so you don't have to delete everything, particularly if you're working through an exam. But I can set in here, in my options, I can find my stats, distribution, binomial distribution, and it said do BPD, otherwise it will accumulate. I'm going to do it from X for 5 events where the probability of success is 0.1. But I'm going to do all of them at the same time. So what I might do is set up another one. Option, stat, distribution, binomial, BPD, and this time X, comma, 5 events, comma, 0.5. And then the third one is option, stats, distribution, binomial, BPD, and this time would be X, still 5 events, but this time the probability of success is 0.7. And I've got them all. You'll see that they're all selected. I've got the equal signs highlighted. I'm going to set my table to go from 0 successes all the way through to 5 successes, going up in ones, and that makes sense. And then I'm going to have a look at my table, and that is actually my table of probabilities for each of these. And so I could copy that across. Now, being a little bit lazy, although it's not fitting too well, I am going to just copy that across using, and I'll get you to consider how you might do that copy yourself. So here's some of the table, and I'll place that here. And then I'm just going to go back and scroll down to get 4 and 5 in as well. And I'll try and be clever if I can, although I think I've already ruined it a little bit. That's better there. 4 and 5, go back to here, and I'll paste this here, and let's see how clever I can actually be. Or maybe, let's just assume I've been really clever. There we go, that'll do. Okay, so there's my table. That's what your table will look like here. And then you can plot these. So for 0, I get 1 is, well, what's my highest? I have to go make sure that I go all the way up to 3, 6, 3, 1, 5, 9. So this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 will be high enough. This goes up to 0.59. Then it goes to 0.328, then it goes to 0.0729, then it goes down to something really tiny, which is what we expected. And then my other ones, the second one, which is I'll do in red, 0.032, 0.156, 0.3124, 3124, 156. This is a really nice bell curvy sort of distribution. The last one I do in green to match its color. That's basically nothing there. It's quite small here, bit bigger there, and then 0.3 there, and then 0.36 there, and then it drops back down a bit there. And so there's my distributions as plotted. It is discrete data, so it doesn't make sense to connect them, but you can see the shape of them, and you can see that the expected value for the first one where P is equal to 0.1 is somewhere in there. The expected value for the second one, where P is equal to 0.5 is somewhere in the middle there. The expected value for the third one, where P is equal to 0.7 is somewhere there. And that kind of makes sense. And that's quite a nice way to do it in your calculator as well. And so that's the end of 15B work. All the best.